Welcome to the CPD session on specifying the correct floor for dance and the performing arts. Brought to you by Harlequin Floors, this presentation was prepared by the world's leading manufacturer of floors for the performing arts, specializing in tenders, specifications, and surveys for large dance companies, performing arts schools, theatres, schools, and universities. The key points we will cover today are what to consider when specifying a dance floor, the differences between a dance floor and a sports floor, the importance of scientific research in dancer health and safety, types of performance floors, some case studies, and finally, the need to consider sustainability when specifying a dance floor. Dame Darcy Bustle, president of the Royal Academy of Dance, once said, "Dancing is an art and the floor is our canvas." Although not all dancers will grow to be famous ballerinas, dancers and performers should be given the same opportunity to train and perform in a safe environment. Having the wrong dance surface can be a significant factor in acute dance injuries. Research has shown that many more injuries occur on hard sports floors or theatre surfaces compared to sprung floors specifically designed for dance. So, what should be the main considerations when specifying a dance floor? Although these points may seem obvious, you would be surprised how often some of these factors are overlooked. Before you start planning the room, be sure to understand the requirements of the end user, such as the dance teacher. To start with, you should determine the genres of dance for which the floor will be used. This is very important as there are different floor requirements for ballet, tap, contemporary dance, where dancers are in bare feet, and other dance types. Different floors have different specifications, such as a particular slip resistance, for example. Circumstances often play a big part too, in determining whether a permanent or portable floor is required, for example, and in deciding whether a sprung floor should be fitted. Current health and safety legislation clearly recommends a professional sprung floor for most applications. Analysing the conditions of the room will inform your decision on key points, such as if there is enough depth to install a sprung floor and whether the subfloor is suitable. Whenever you make these decisions, you should ask yourself if the floor you are specifying poses an injury risk. Knowing the type of dance the room is intended for will also enable you to determine the ideal fittings, such as mirrors and ballet bars. Acoustics can be an important consideration, particularly for percussive dance where the sound of the steps is an integral part of the performance, and they matter for the music which accompanies the dance. In certain spaces, the sound which is carried outside of the room will also need to be taken into account. And finally, a key factor to consider is, of course, the budget. There may sometimes be a temptation to sacrifice other aspects for this one, but bear in mind that having to replace the floor after it has been fitted will be way more expensive than choosing the best floor from the start. This is a picture of an ideal dance studio. The overall space should be adequate for dance, approximately 5 square meters per pupil for teenagers and adults, reducing to 3 square meters per pupil for children. There should be enough height for dancers to perform lifts. 3.5 meters is ideal. Bars are used for warming up, stretching, and to steady the body while practicing technique. They must be securely fastened. Mirrors are used for self-correction and grouping. Air conditioning is often required when working in a hot environment. A temperature of between 21 and 24 degrees Celsius is considered ideal for a dance studio. The acoustics of the room and a need for music should also be considered. And the most important consideration is the dance-specific sprung floor and performance surface. Dancers who have trained and performed in many different places recognize a good floor instinctively and will be able to tell whether or not it feels right underfoot. The aim is to provide them with a floor which allows them to focus on their dancing and effectively forget about the floor, as an unsuitable floor can distract a dancer from their performance. As fitness and good health are vital to a dancer's career, it is a great boost for their confidence and reassurance to know that the floor minimizes the risk of slipping and falling. Less immediately noticeable, but no less important, is the right amount of energy absorption and energy return, especially when performing jumps and lifts. This quality of the floor can help prevent long-term injuries. And it should not be forgotten that although dancers are not always the commissioning clients, they will always be the end users. If a dance floor is too hard, the shocks from every step and every jump are not absorbed enough, potentially leading to repetitive strain injuries. Every dance step and jump on an unyielding surface wears down the resilience of the body and brings about the risk of injury and the prospect of long-term damage. However, if the floor is too soft, no energy is returned to support the dancer during the movement. This can be tiring for the dancer and lead to fatigue-related injuries. An appropriate level of slip resistance or traction on the floor surface is very relevant to the dancer's safety. Too much and it could block movement and cause the foot to twist during spins and sliding movements, but too little can make the floor dangerously slippery. A dancer's interest in the quality and consistency of both the sprung floor and the dance surface is for artistic performance as well as health reasons. Steps and jumps are responded to by the quality of the floor underfoot. A dance studio is essentially a dancer's work environment, the floor being the tool that is fundamental part of their work. Floors developed for general industrial, commercial, or even sports applications do not offer the benefits that dancers need. Only floors developed specifically for dance do that. It is a common assumption that a well-designed sports floor will meet the needs of dancers. This is not the case, as there are significant differences in the construction of the sprung floor and the performance surface. Having looked at the details of how a dance floor should be structured, let's find out why a generic sports floor does not meet those criteria. Although some shock absorption is required, most indoor sports require a high degree of energy return, and the main focus of the floor is often the need for an adequate ball bounce. Evidently, dancers have little interest in ball bounce. For them, the energy properties of the floor matter for their own bodies. Dancers are focused on a combination of shock absorption and energy return that a sprung floor can provide. In comparison to sports people, dancers need more absorption or cushioning to protect their limbs during landings or after jumps. One reason for the different requirements is simply the difference in footwear. Whereas indoor sports people can tolerate a stiffer floor as they usually have cushioned footwear, this is not a luxury available to dancers, whose shoes tend to have softer, thinner, and therefore less cushioned soles. For some types of dance, performers wear no shoes at all. It is therefore not surprising that slip resistance is one of the main criteria which dancers consider when it comes to the performance surface. Currently, no standards exist which relate specifically to dance floors. The closest available and most widely used is the standard for sports surfaces for multi-use sports, the European EN 14904, which has essentially replaced the German DIN 18032-2. However, this standard was designed to create the ideal floor for sport, not dance. The test for EN 14904 measures the following 6 criteria. Ball bounce. Generic sports floors are designed for the energy return of a ball rather than a person. The force reduction test measures the degree by which the floor reduces the impact force, which occurs when an athlete or dancer lands on it. The test was devised to simulate the forces observed when a runner's heel strikes the ground. In the vertical deflection test, the amount by which the floor deflects under impact load is measured directly. The test is similar in principle to the force reduction test, but a softer spring is used and the drop height is adjusted so that the peak force which is produced falls within a certain range. Slip resistance. A specialist tool is used to measure the slip or traction of the floor surface. The rolling load resistance test is carried out on 2 structurally critical areas of the floor. A steel wheel is loaded to 1500 newtons and is rolled repeatedly over the surface of each area. After 300 passes, the floor is examined for damage. Area deflection is measured using a modification of the vertical deflection apparatus. Instead of measuring the deflection at the point at which the test force is applied, it is measured 500 millimeters away. The purpose of this test is to ensure that one athlete or dancer standing on the floor will not be excessively disturbed by the movements of another nearby. As you can see, these tests do not necessarily focus on criteria relevant to dance. Some styles of dance, such as ballet, require traction from the floor to prevent slips during a performance. But too much traction for a basketball player, for example, blocks movement, potentially resulting in twisted ankles or knees. On the other hand, the basketball player will need the 90% ball bounce specified in DIN 18032-2, something that is completely irrelevant to the dancer. So, these standards can give some indication of a dance floor's qualities, but cannot be relied upon to check that you have specified the correct floor. It is worth bearing in mind that specifying the wrong floor can have severe economic consequences. As we have seen, relying on a floor standard alone when specifying a dance floor could lead you to choose a less than ideal floor. There may be a temptation to specify floors for aesthetic reasons, or to specify sports floors in the mistaken belief they will be suitable for dance. Needless to say, replacing floors after construction is an error which should be avoided, as it is both expensive and damaging to the architect's reputation. Having spent some time on the requirements for a dancer's health, let's take a look at the research which informs these requirements and the developments it has resulted in. Dancers all too frequently suffer an injury which will stop them dancing. Thankfully, for most of them, it only means a break of a few days, but for a few, their injury can be career-ending. This is why creating a safe environment is so important. The development of dance floor technology has progressed significantly in recent years, thanks to a strong relationship between the dance community and the industry to produce floors that are right for dancers. Instead of just putting new floors on the market, responsible manufacturers now take the time to consult with professional dancers during the development stage of their product. Medical research has provided valuable insight into injuries to which dancers are prone and their causes, while performance floors have been developed to reduce risks of injury using medical and scientific research from dance health organizations such as IADMS, the International Association for Dance Medicine and Science, and NIDMS, the National Institute for Dance Medicine and Science. One such study has found that the consistency of the floor is extremely important. Let's listen to Dr. Luke Hopper, Vice Chancellor's Research Fellow at the Western Australian Academy of Performing Arts, to find out why.
But nonetheless, in this study, we were able to take a drop mass from that I described in the previous videos and go around to different stages that a company was regularly visiting on their touring schedule. And the schematic on the screen here represents the stage that we found the dancers were experiencing the most injuries on. And so we can speculate about why the injuries may have been occurring more frequently on this venue compared to the others. So you can see here in this schematic, the top line here represents stage front. So this is stage front. This is the front of the stage that they were facing the audience with. And you can see here we've got these blue lines going through the stage, both from front to back and from side to side. We referred to them as the primary supports because they were effectively big steel girders. They were the big main support structure that was holding the stage up. And on top of the primary supports, you can see we've got these yellow lines, and we refer to them as the secondary supports. They were metal bars as well. They weren't as big as the steel girders, but they were sort of these box-like structures that created these sort of 1 meter square boxes across the stage. So we took our drop mass and we measured on all of these points here. You can see here we measured along the corners and along the lengths of the primary supports, and also on and between the secondary supports in 2 separate locations. And the blue and the chart below here represents the values of force reduction that we got on those different points. So you can see here on the primary supports we were getting quite low force reduction, but I think the key thing here is that on the secondary supports we were getting really quite varied force reduction values. So this means that depending on where the dancers were landing on the stage, they could hit a spot here that's up sort of almost at around 60%. So it's quite a sprung part of the floor. But then right next to it, if they landed on directly on top of one of the supports, they'd be hitting a bit of floor that was about 30% force reduction. So really quite hard. And so it was inconsistent, and because it was inconsistent, the dancers really couldn't tell when they were dancing around the stage whether they were going to land on one of these bits here or one of these bits here. And that represents a real problem biomechanically for a dancer, because remember, the dancer has to engage the muscles that cross the ankle to reflect what they think the force reduction of the floor is going to be. So it's a problem if they can't predict what the force reduction is going to be. How are you going to create this stiffness across the ankle and stabilize the movement of the foot if you don't know what the floor is going to be like? So that's why we think that this floor had the most injuries on it, is because it was the least consistent and it was the least predictable. Some of the stages were a lot harder. We measured a couple of the stages and they were all sort of around this 20 to 30% mark. So they were really quite hard. Certainly didn't meet the industry standards, but we didn't see as many injuries on them as we did on this inconsistent surface here. So I think that's a really important factor to consider. It's not so much only that a floor may not be sprung, but that it's consistent across the floor is a really important thing to think about for your dancers.
Bonnie Rietveld MD was the head of the Dutch Medical Centre for Dance and Music and former president of the International Association of Dance Medicine and Science. As an expert on dance injuries, he can explain the causes and the effects of such injuries on his patients.
The mission of the Medical Centre for Dancers and Musicians in The Hague is to take care of dancers' healthcare, dancers' health, which means that we treat dancers who are injured, which means that we make diagnoses, and especially that we try to help them in preventing injuries in any way we can. First is primary prevention, which means safety, which means a good dance floor, which means a floor which is not too slippery, a floor which has a good shock absorption, which has a good, comfortable feel to it. Secondary prevention means that if you're feeling a certain pain or a certain discomfort, you're aware of this and you stop with what you're doing and you prevent it from getting worse. So that's different than primary prevention. And then tertiary prevention is you have had an injury, you've learned your lesson, hopefully, you realize why the injury took place and you try to prevent it from happening again in yourself, and if you're a teacher, in your students. Up to 90% of dancers get injured. So you learn to deal with injuries. You learn to deal with the fact that injuries are part of a dancer's life and that you have to really take prevention seriously. And also, I quite often hear that dancers feel that they are more profound in their dancing expression when they've gone through a difficult phase like an injury. So yes, it can be a very positive experience. A good dance floor has a certain feel to it. I'm not a professional dancer, but if a dancer steps into this room and they see this little part of dance floor right down there, they will step on it, they will feel it, they will feel if it's slippery, they will feel the grip of the floor, they will bounce on it and they will feel it's okay. So it's hard to tell what exactly makes a good dance floor, but every professional dancer feels it immediately. And quite often I have visitors in this clinic and I always ask them to briefly jump on the Harlequin floor and then jump on the side of the floor. And even somebody who has never jumped in his life, they feel immediately the big difference in shock absorption and spring effect. So it's a combination. But the feel of the floor, also the grip and slip, that is something which a dancer can feel much better than any individual not so well trained. It's interesting to realize that in dance there's hardly any protection of the shoes. They're dancing barefoot, or they're dancing on very thin split soles or on point shoes, and they usually go to the extreme position of the ankle and foot joints, which means that there's a direct bone against bone, knuckle against knuckle effect on the bone. There's no shock absorption of movement in between. If your foot is in full demi-plie, it means that the bone is actually touching the front of the foot. And if then you have a bang on the floor, if the floor is too hard, it will cause immediately irritation of these bony surfaces touching each other, which will result in either osteophyte formation, so which means early degeneration or abutment, impingement of soft tissue. So that's a common injury type we see in dancers dancing on too hard floors. And another important type of injuries are the overuse injuries of the soft tissues and the bones, which is shin splints and stress fractures, to name just two important ones. And they are very common in dancers, especially if dancers are compensating for insufficient anatomical parts of their body, for instance, insufficient turnout, limited demi-plie, or a cavus foot, which is an arched foot which has less shock absorption by itself. So there's these two types of injuries, stress fractures due to overuse and impingement type injuries which cause osteophyte formation and degeneration of the joints.
As we have seen, floors developed for general industrial, commercial, or even sports applications do not offer the benefits that dancers need. Only floors developed specifically for dance do that. As there are also many different styles of dance, different types of performance floors have been developed to suit their requirements. What are the different types of performance floors? First, let's take a look at a sprung floor. Sprung floors are sometimes referred to as a floating floor system. They are designed to absorb impact energy created by the dancer. If this energy generated is returned to the body, it can result in an array of joint problems, sprains, fractures, knee problems, and tendinitis. A dance floor that is impact absorbent and provides lateral foot support is essential. Sprung floors also provide energy return to lift the dancer's feet during jumps, but these floors are not bouncy like a trampoline. Historically, dancers performed on either wooden floors or lino. Purpose-developed vinyls were not brought in until the 1970s, when there was a desire for floors to have a bit of give in them. Sprung floors often use coil or leaf springs, but these were considered too bouncy for ballet or contemporary artistic dance needs, often referred to as the trampoline effect. In the last 50 years, metal springs have given way to resilient blocks or pads made of rubbers or polymers. With modern floor construction methods, the trampoline effect of the early sprung floors has been suppressed, allowing performers to have a much more natural feel for the floor. To better understand how to avoid the undesired trampoline effect, we must understand the difference between a point elastic and an area elastic floor. An area elastic floor flexes over a relatively wide area, but keeps the deformation fairly low. A sprung floor is area elastic, as it moves by a maximum of 5 mm to reduce force and return energy. This means that in everyday situations, it will move between 3 and 4 mm at the point of impact. To avoid this movement affecting other performers, scenery, etc., the deformation is gradually reduced the further you are from the point of impact. At a point 500 mm away, the floor deflects by less than 1 mm. Point elasticity, as the name suggests, is give only at the point of contact, and is achieved by using a thin foam layer as part of the performance surface. There are different types of sprung floor available to dancers. The floor can be constructed from panels, laid materials in a sandwich construction, or a basket weave made from wooden battens. Quality sprung panels are made from top-grade birch ply, backed with dual-density elastomer pads. They are laid in a brickwork fashion and slot together. In a permanent installation, they can be fixed together using glue or screws, but some sprung panel systems come with a one turn of the key locking mechanism. Typically, these sprung floors are designed to offer a choice of permanent, semi-permanent, or portable installation. A triple sandwich construction is so called because of its multi-layered design. This is a fully floating system with no fixings to the subfloor, and it can be laid on any reasonably smooth and flat surface without prior preparation. A basket weave design is the choice of many traditional dance companies. It should consist of 3 layers of interweaving wooden battens. The third layer and the offset suspension panels remove the hard spots associated with batten-type floors. Most sports floors are only double batten floors. The sprung floor will nearly always be covered with a performance surface, which can be made from different materials. Performance surfaces should be specified to suit the type of performance on the floor. Generally, they are made from vinyl or hardwood, and they have varying degrees of cushioning, durability, and grip or traction. All these qualities will be desired in varying amounts depending on the performance type. It is therefore essential to specify the right surface for the planned activity. Some performance styles still use wood, most now use some sort of vinyl surface. The vinyl can be glued and welded for permanent installations or taped for temporary or semi-permanent use. Many performance surfaces are available, but they can be broadly divided into those with a foam backing and those without. The foam backing makes the floor flex at the point where the feet and body make contact. They are point elastic, so are enjoyed by contemporary dance styles with their rigorous floor work. For percussive dance styles such as tap, flamenco, and Irish dance, foamed back floors are not suitable as the foam dampens the sound. It should be noted that cushioned vinyls are not a substitute for a sprung floor. Wooden floor surfaces are often an aesthetic choice. The surface can be constructed from engineered wooden boards, in which case a solid hardwood layer will form the top part of the dance surface, or it can be made entirely from solid hardwood. In either case, suitable types of wood which can be used as a performance surface on top of a sprung floor includes hardwoods such as beech, oak, and maple. Sustainability is taken very seriously. In the dance world, this mainly concerns material sourcing and recycling. By specifying an FSC certification, you can make sure that the wood used in manufacturing the dance floor was harvested from well-managed forests. Wooden floor panels should always be made from wood that is ISO 9001-2000 certified and meets international standards. Vinyl is the most versatile and extensively scrutinized polymer available. It is classified as a thermoplastic, which means it can be recycled repeatedly without loss of performance. In addition, it is worth checking whether the floor you are specifying complies with other important environmental or sustainability criteria. For example, vinyl floors should ideally have Intertech Clean Air Gold certification, which is LEED version 4 compliant. An A+ rating in the BRE Green Guide to Specification is another good indicator to look out for, and of course the floor must comply with relevant registration, evaluation, and authorization of chemicals regulations. No formaldehyde should be used in the production process of wood or vinyl floors, and they should comply with BREEAM Class E1, and the flooring manufacturer or installer should ensure the recycling of any products remaining on site. Let's go through some practical examples of how different spaces were equipped with a suitable floor. Shakespeare's Globe Theatre in London selected a triple sandwich construction sprung floor with a dual purpose, for both its shock-absorbing and acoustic properties, which contained sound within the studio's performance areas from the rest of the building. The sprung floor was covered with a hardwood performance surface. The Princess Grace Academy was founded in 1975, following Princess Grace and Prince Rainier III's desire to establish a high-level dance school in the Principality of Monaco. The aim of the academy is for students who are aged between 13 and 18 to learn the vital dance skills they need in order to progress to an international dance company at the end of their studies. Princess Grace Academy has 5 studios equipped with the highest quality sprung and vinyl floors. The newest studio was built in 2022 when the director, Luca Masala, chose an activity sprung floor with a studio vinyl top surface. The Royal Opera House has a custom-built ballet wagon, which is a flexible storage and transportation system for its stage floor. It was specially created with a steel frame foundation, over which a triple layer of sound-insulating acoustic foam is laid, with a bespoke modular wood-sprung floor panel sitting on top. Additionally, all 3 Covent Garden ballet rehearsal studios housed at the Royal Opera House have a wood-sprung floor panel system installed and finished with a high-performance vinyl dance top surface. All the dance and performance surfaces at the Royal Opera House are consistent and provide the dancers with assurance for better protection from injuries. Home to Queensland Ballet since 1991, the Thomas Dixon Centre in Brisbane has been transformed into a world-class performing arts destination. It features 6 new studios, including a community studio, which all have a Liberty sprung floor panel system and studio vinyl dance floors. The new 351-seat Talbot Theatre is also fitted with the Liberty sprung floor, WeatherTech stage surface, and a roll-out Harlequin Studio vinyl dance floor. In 2022, the Royal Academy of Dance opened their new international home for dance, their headquarters in Battersea, London. The award-winning building has 7 large dance studios and a 193-seat performance space, the Ord Jemison Studio Theatre, all equipped with over 1,200 square metres of activity-sprung floor and Cascade vinyl performance floor. Each studio has bespoke ballet bars and mirrors. The RAD required bespoke colours for the ballet bars to match other RAD furnishings. The mirrors were water-cut to fit the wall-mounted ballet bars directly to the walls to create a seamless and neat finish. The Théâtre National de Chaillot in Paris was a major stage flooring system installation. Designed by Paris architect Vincent Brossi, the project required a flexible multi-purpose solution. The specification included retractable seating, a hard-bearing stage floor able to withstand high loads, and a high-performance sprung dance floor. The solution was a 475 square metre bespoke stage system comprising sprung floor panels overlaid with a vinyl dance surface. Yuen Long Theatre in Hong Kong opened in May 2000. The theatre houses a 923-seat auditorium, a dance studio, a rehearsal room, a lecture room, a function room, and an exhibition corner, providing a wide variety of facilities to meet the needs of venue users for a wide range of cultural and entertainment activities. Yuen Long Theatre has renovated its theatre stage using Liberty Switch, enabling a diverse variety of performances at the Hong Kong Theatre. Liberty Switch is a revolutionary, award-winning professional multi-use flooring system which transforms between a sprung dance floor and a rigid theatre floor at the touch of a button. It is designed for venues which regularly put on both dance and theatrical performances and so require both a sprung and a rigid floor in the same performance or rehearsal space. Liberty Switch enables a Liberty sprung floor system to be transformed to a rigid, unsprung floor, quickly and easily. This is achieved by using moving carriages which engage with stop blocks on the underside of the Liberty panels to create a rigid floor and disengage to create a sprung floor. This new system is more sustainable than the traditional alternative of using a portable sprung floor or ballet wagon. Having one multi-purpose floor instead of 2 separate floors uses less resources, and the floor does not need to be stored, moved, installed, or uninstalled for each performance, so reducing the manpower required and energy consumed. When speaking to professional dancers, you will probably find that most of them know the name Harlequin. Here is what you need to know. Harlequin is the world leader in floors and studio equipment for dance and the performing arts. The company was founded in the UK in 1977 and has built its reputation on the manufacture and supply of portable and permanent sprung and vinyl floors, ballet bars, and studio equipment for dance theatres and performance spaces. Harlequin works in collaboration with architects and contractors on a wide variety of projects, including installations in schools, universities, and independent dance companies, from the initial design to final completion. Harlequin also works with leading architects and stage consultants to design, build, and install bespoke theatre stage systems. The world's most prestigious dance companies and schools choose Harlequin floors. They know that they can trust Harlequin to provide them with the best dance floor systems available, all researched, designed, and manufactured in association with dance medicine professionals. Harlequin has renowned clients around the world. Those in Australia include the Australian Ballet, Australian Dance Theatre, Sydney Opera House, Bangarra Dance Theatre, Queensland Ballet, West Australian Ballet, and the Arts Centre Melbourne. Harlequin is specified for the education sector Australia-wide, including schools, universities, and all education facilities. Harlequin has led the way in developing and evolving modern sprung dance floors and has been involved with extensive research into reducing dancer injury. Harlequin's extensive range of sprung floors include permanent and portable systems suitable for a wide range of applications. Harlequin also offers expert installation by our in-house technical team. The Harlequin range of sprung floors includes Harlequin Liberty, a modular panel-based sprung floor system featuring dual-density shock dampening elastomer pads, ensuring uniform and consistent shock dampening across the floor. The panels join together quickly and simply using Harlequin's proprietary one turn of the key latch and lock mechanism. Harlequin Flexity is a cost-effective, self-install, sprung floor panel system manufactured from selected birch ply panels with shock-absorbing elastomer pads which join together using Harlequin's unique tongue and groove system. Harlequin Activity is a fully floating sprung floor system without fixings to the subfloor, constructed using Harlequin's proprietary triple sandwich construction method, created over 30 years ago. Harlequin Activity provides shock dampening to avoid a trampoline effect, plus area elasticity to offer identical characteristics across the whole floor, offering better protection from injuries for both teachers and performers. Harlequin Woodspring is a modern update of the traditional basket weave construction. It is comprised of a layer of select plywood, a triple layer of custom machined southern yellow pine with dual density elastomer blocks attached to the underside. And lastly, new Harlequin Liberty Switch, a revolutionary award-winning professional multi-use flooring system which transforms between a sprung dance floor and a rigid theatre floor at the touch of a button. It is designed for venues which regularly put on both dance and theatrical performances and so require both a sprung floor and a rigid floor in the same performance or rehearsal space. All Harlequin sprung floors are designed to be used with a variety of performance surface options, from the Harlequin range of performance vinyl floors and solid or engineered wood finishes. Harlequin's range of performance vinyl floors can be laid on any hard, smooth subfloor and used alone or as a dance surface on a sprung dance floor. Harlequin offers a wide range of vinyl performance floors suitable for many applications. Harlequin Cascade is Harlequin's flagship professional vinyl performance floor, used by the world's leading dance companies and dance venues. As a hard-wearing homogeneous vinyl, it has a slip-resistant, smooth dance surface and is ideal for use in dance studios, theatres, concerts, and as a high-quality base for lighting designers and photographers. Harlequin Studio is a hard-wearing, slip-resistant vinyl performance floor designed to meet the needs of dancers. It features a lightweight closed-cell foam backing to provide protection against hard subfloors. It is ideal as a multi-purpose dance or stage floor. Harlequin Reversible Pro is a double-sided vinyl performance floor featuring a mineral fiber interply layer, making it dimensionally stable and an ideal surface for printing. It is a lightweight, hard-wearing calendared vinyl with a slip-resistant performance surface on both sides. Harlequin High Shine has a unique scratch-resistant, high-gloss display surface which creates a striking reflective finish. It is a hard-wearing and reusable vinyl floor, ideal for touring or high-traffic environments. Other vinyl performance floors are available. Please contact us for more details. That concludes this CPD presentation from Harlequin Floors. Thank you for listening. For more information and advice, please visit our website or you can contact us by email or phone. Alternatively, you can find full details of Harlequin's range of products, including downloadable BIM objects, by searching for Harlequin on Archify.com.